And here we are in the lab again today, and I got a shipment from PCB Way, and so that means that I have new cards for us to put together, because I also got a shipment the other day from Mauser. So we have parts. So that's the next step is I usually stick the board under the microscope and just check to see the quality, and just look at it, because I used to use a different company, and they were a little more sloppy, and sometimes they'd have just a little stuff on there. Not too bad. But PCB Way, they do really good. I've never had a problem with them. I got one that had a little bit of foreign material on it, nothing serious. And you might want to check and clean it with some alcohol. I use denatured alcohol to clean. It's kind of getting harder to find, but you can still get it. You can order it online if you have to. But you can use acetone, but when you make PCB material, you use acetone in the chemistry. So I'm always worried that it might wipe off some of the board or something. I just don't like the idea of using the same solvent that it's made out of. But alcohol works good, it's cheap, and that's basically what I use. And so, yeah, let's look under it. Let's see if we can get the microscope to work, because see, the thing is about the microscope, when I have the camera on, it takes up one of the one side of the vision. So when I look in it, I only get one eye. So it's a different thing when you only have one eye on your microscope when you're trying to solder and stuff. So we'll see how that works. But yeah, we'll get down under the microscope. We'll just do a quick look and see how it is compared to what we drew on Fusion. And then we will get the parts together and we'll start putting them on. Oh, yeah. And then we're going to have to fire up the oven, because the I/O connector here, it has to be done in the oven. So we'll get the oven fired up, and I'll show you how we do the I/O connector. And then I think probably after the I/O connector, we'll have to probably put the I/O chips on there and play around with that in the code and stuff, because one thing I wanted to mention too is the old way to do it would be, before you order the PCB, you would prototype the board, and the way, as cheap as these PCBs are now, you can, and Fusion really makes it so you make less mistakes, because it links the schematic to the PCB. So there's not really much, especially with surface mount, there's not really a real incentive to prototype the circuits first now, because you can order a board, pretty cheap, and Fusion is pretty accurate, and you don't make a lot of mistakes. So the only thing would be if your design is flawed, then you'll have to probably cut some traces and add wires and stuff, but you still have a board to work with, and it's clean. And with surface mount, you have to add, if you prototype, then you have to get a little surface mount adapter board, so you can solder on the surface mount component you're using, and then that converts it to through holes, so you put that on male headers on on a through-hole PCB, and that's kind of expensive. I mean, you're going to spend way more money on proto boards than you are on these PCB way cards, and you don't get very good signal noise ratios out of it, because when I prototyped my motion board for the first time, I got a lot of like, the inductance was way different than the PCB board, and I'd blow the chip sometimes, the controller chip. But since I got my circuit set up the way it works good and everything with the PCB, I don't have any trouble with any kind of like noise or crazy conductance and stuff. So inductance, crazy inductance stuff. So yeah, I guess the next step, let's get it under the microscope, see what it looks like, and then we'll start soldering and run it through an oven cycle and solder that connector on there. All right, so here we are looking around the board, just kind of randomly looking, checking out the vias and the traces and the pads, make sure we don't see any anomalies. It looks really good. I hardly ever see any problem with PCB way. They got their stuff going on. They got it down. They're doing good. Those are tight traces too. Looks like maybe we could have made some of the characters for this silk screen a little bit bigger, for like where the output connectors are and stuff like that. And there's our I/O connector there, looking good. Pads look good. Looking around, letters look good. Yeah, I like it. Good quality. If you get noise on that board, you designed some bad stuff. All right, and there's our bus transceiver and the back side of the board. Vias look real good. Traces look real good. Pads look real good. Look at that. Not bad. All right, back over. I'm looking at the I/O connector pads. So the next thing we're going to do is put the I/O connector on there, match it up with the pads, make sure it fits with the holes and everything, and then we'll fire up the oven and solder that bad boy on there. All right, so get the connector up here, slipping it on the board, and see it has little pegs on it, little pins that go down in the holes in the board. Oh yeah, fits good, looks nice. But that's kind of a copy from other boards, but so we expected it to look nice, but yeah, it fits really good. So here's the solder paste that I've been using. Seems to work okay, but it's getting kind of old. But you should keep it refrigerated. But it used to be a lot more runnier than it is now. But it still works. It's okay for what we're doing. So I'm just going to run a bead down the back, because that's all I'm really going to, and then maybe a couple pads on the end. But if you were doing production, then you'd want to like get a stencil and then screen print it on and get the right amount and just do the whole board. But since this is a prototype and we're doing engineering type work here, I'm just going to run a bead down the back, and they're all connected. The back row is all grounded together anyway, so don't worry about how much solder I'm putting on there. I'm trying to keep it even, but it's not a critical thing right now. And as long as that back row is grounded, then you got good signal ground. So that's all we care about, really. Can't really see it, and you know. So then we'll do the front by hand and make that look good, and then we'll start putting more parts on. All right, so now got our little hypodermic needle of solder paste, and we're going to do this back row of the connector. Put a couple drops on the pads so that the main body is soldered to the board, and it won't stress out any pins or anything while we're banging it around. So you just have to get some on there. When it reflows, it'll just flow around the pin, and those on the outside, we could get to those. And then here, this is where the criticism's going to come in. But yeah, just run a line down there. They're connected together anyway, and the solder will flow to the pins and the pads. So it's fine that way. It's not to production standards, but like I said, it's a prototype. So if there's any problems, we can try to fix it. So now we get the connector and try to put it on without smearing the solder paste. And I kind of had a bumpy landing here. It's kind of hard to like do the camera and stuff at the same time. But yeah, there it is. It's on there. Alright, so we got our solder paste on the board, and we got our part on the solder paste. So now it's time to get the oven out and reflow the solder and attach that connector permanently. Alright, so now we get our trusty reflow oven out and plug it in and turn it on. And then you see the menu system is just kind of messed up. They didn't spend enough time on their menu system. We'll do some menu systems too and read buttons and make decisions on it. But anyway, there's various waveforms in there, and you select which waveform you want. It's not too critical just soldering on a connector, but it should be kind of hot with a longer dwell time. Waveform 3 would work real good. I used waveform 1 on this one, but yeah, that's the waveforms, and you select which one you want. I selected waveform 1. 1 or 3 is pretty good. See how the menu system, even though it's English, it still has 1 in there. See how it has some Chinese writing still up there at the top. But anyway, once you select it and you press start, then it starts heating up. So that's the menu system. So now we'll get our board and put in the oven here. Open up the oven. This kind of slides open. It just has you can just set the board on there. If you're soldering the bottom ones, that's a whole different thing when you solder the bottom ones, because you have to put a little dab of silicone RTV underneath the chip and put the chip on atop the solder paste, and then the silicone has to dry a little bit and hold the part on there while you put it in the oven. And then you have to raise the board up off a little bit, probably, maybe not. You could get away with setting the chips directly on there. But then you start it up and you start reflowing, and it'll turn that infrared lamp on and heat everything up based on your profile. It'll follow that profile curve, the waveform that you selected. And see, the lamp just turned on. So it's going to follow that curve up, turning the lamp on and off. And so then after 7 to 15 minutes, it will do its thing and cool back down. And the board's still pretty hot at this time, so you don't want to grab it. So I use a pair of tweezers. I just got these tweezers in an auction, and it was in the bag with the auction stuff. And it's kind of cool tweezers. there's our board soldered and ready to look at and see if we did good or bad. So let's put it under the microscope and find out. Wait a minute, wait a minute. I just thought I got rid of that. Alright, here we go. Okay, so let's take a look. So it looks like we got a lot of solder balls. So that's probably because my solder paste is getting old and doesn't have enough flux in it. But we'll just have to deal with that for right now. I don't think it's a big concern because it's stuck on there with the flux from the solder paste. Maybe we could have held it a little more longer dwell time when we soldered. I'm not too happy with that. I don't think it's going to cause any problem for right now, so I'm just going to let it ride and see what happens. We'll have to verify that the pins are soldered down, and I believe they are. It's just I probably got a little too much solder paste on. Okay, so there's our soldering iron. We got some flux. You should have a sponge to clean your tip. And yeah, missed it there. That's a new bottle. We're gonna have to fix that, it looks like. But yeah, you want to get your sponge nice and wet with just regular water, so you can wipe your tip. You have to wipe your tip a lot. You got to keep your soldering tip clean. All right, and you got some alcohol there, some flux, alcohol, Q-tips. I was trying to show the alcohol can, but the lamp's in the way. So it's just like get some alcohol, denatured alcohol from Home Depot or someplace, ordered online, however. All right, so there's our board. And we're going to do some hand soldering. Alright, so we'll start on these two pads on the end of the connector up here. Add a little bit of solder. Reflow it. That cleans up that other soldering that we did in the oven. Alright. And go down to the other end. A little bit of flux. This is no clean flux, but I always try to clean it because if you didn't clean it, it looks pretty funky. I mean, if you're going to put it into a case or something, nobody sees it, then it don't matter. But, yeah, it doesn't affect it at all electrically. I mean, zero. But it just looks like crap. And you should clean it with the alcohol right after you solder it, because once it cools, it gets kind of hard. You'll see that here in a minute. And so now we're going to do the pins. So we're going to get some flux on there. Then we're going to just solder one pin at a time. That's the proper way. You got to make sure that the solder flows not only on the pin but also the pads. And these pads are so small, I have to put a little bit excessive, go a little excessive on the solder. Technically, by IPC standards, that's a little too much solder. But I mean, for what we're doing, it's fine. The main thing is to get that solder flowed down onto the pads so that it connects connects that pin down onto the pad. And just keep going. Just keep going one by one. Some people drag their soldering iron across the pin so they can do it faster. That is just not the proper way, and you can cause solder shorts and excessive wear on your tip. This is a met cowl, so they got really strong tips and very durable, but they're not cheap. And you want them to last as long as possible, and the met cowl tip will last. If you take care of it, that met cowl tip will last forever. But you start prying on leads and dragging it and scratching it and digging with it, it's not going to last for very long. All you have to do is just one at a time. It doesn't matter if you're soldering 1 pin or 1,000 pins. You just got to do it. See right there, it didn't flow enough down onto the pad, so I have to hit it again. There you go. And then, so yeah, no matter how many pins you got to solder it one at a time if you want to do it the right way. You don't want to. You want to hold it on the soldering iron on the pin until it flows to both the pad and the pin real well. And you don't want to hold it too long or push too hard down on the board. It can discolor the solder mask on the board. You just want to keep moving along. And wipe your tip. Just keep your tip clean. See right there, I got some black buildup from the flux. Yeah, it's time to clean that bad boy. It's time to get that off. It's working pretty good still, but it'll cause you problems sometimes. It's not building up too bad. But yeah, I should have cleaned that by now, but it's doing good. We're doing okay. The microscope, the camera doesn't have quite a wide of a field of view as I do when I'm looking through it, so it's hard to tell when I go outside of the view of the camera. So there, my tip's clean, got some fresh solder, getting it down on there. So there's that. So we pretty much got our connector soldered on, so now we just want to clean up that flux and any other residue on the board. So looks like there's some residue and some tiny solder balls right there on this connector from being in the oven. And I maybe didn't get enough flux when I hand soldered it, but anyway, it dried, and if I would have cleaned it right after I soldered it, it probably would have come off. But we can just very gently scrape off that flux, and that'll help the alcohol get down and clean it off. There we go. That's not too bad. So now we just want to go down and clean off the rest of the pins with the alcohol on the Q-tip. And see, I didn't get all the pins in there on the and the field of view. But there you go. Just go across it like that. You can see it's picking up that flux. And just run over it with the Q-tip. And you don't want to dip your Q-tip back in the alcohol after you've picked up the flux. So you use the other end of the Q-tip, keep it fresh. Q-tips are cheap. I use a lot of them. You don't want to wipe the board with dirty Q-tips because it'll spread that flux around. You want to keep it as clean as possible. And that flux gets everywhere. It'll cover, you'll be cleaning here and there. Okay. Everything's done except I want to clean up in the back row a little bit, get some of them solder balls out of there, because there is a danger with solder balls that they'll come loose and roll around and short out a couple pins or something, and you just don't want to add anything like that into your already troubled system. So yeah, we'll just take something skinny and sharp and gently go in between the pins and just kind of knock that flux loose back there, and just loosen that stuff up, and then we'll flush it off with alcohol and Q-tip. And yeah, just clean it and loosen up that stuff in the back, and yeah. Looks like the one side is a little bit heavier than the other side. This side right here is a little bit heavier than on the right hand side. But it's just flux and some little solder balls is all it is. There's like no solder shorts or anything. And we'll take a closer look. We'll zoom down in here in a minute and look and see how it does. The solder paste flux is kind of a little bit gooey. But I'm gonna have to get some new solder paste and keep it refrigerated. And maybe for the heavier components like a connector, maybe run a little longer dwell time in the oven. Alright, so we got this cleaned up a little bit. Let's zoom in there a little bit and see down in there and see what it looks like. So you can see it cleaned up pretty good. I mean, there's still stuff back in there. And you could flush it more with alcohol and maybe try to get a toothbrush in there, but it's actually not bad right now. It's doable. If there was anything loose, we knocked it loose and cleaned it out already. Alright, so there you have it. We got the connector soldered on and it's ready to go to the next step. So what we'll do now in the next video, that'll be it for this video because it's getting kind of long. So the next thing is we're going to take and do the support chips for the interface chips and get those on, which is the 244 and 245 buffers and the LS38 or AC 138 for the memory decoding. And I noticed that when I ordered the jumpers, it was 8 pins, not 8 rows of 2. So, but I got headers we can put in there. And you only need one anyway to select the board address. But yeah, we'll put that on there so we can plug it into MainBrain, and then we'll look at the waveforms and we'll write a little code and we'll see if we can get the multi-board interface up and working. And then once that's smoothed out and working, then is what we'll do is we'll start putting on the rest of the parts. We'll get the microprocessor on there, or microcontroller on there, and the ICSP header and the rest of the stuff. Then we'll write some more code and look at some more waveforms, and then eventually we will put it in action and try to input some signals to the I/O card and output some, switch some, put it through its paces and see if it works and see what we need to do better. And maybe we want to delete something out. Who knows? We'll just see how it works and go from there. So I'll see you in the next video.